Hello there. Welcome to my YouTube channel. Today I will take you through heat conduction through a hollow composite cylinder in heat transfer. Let's tackle this question. Hot air at a temperature of 65 degrees Celsius is flowing through a steel pipe of 120 mm diameter. The pipe is covered with two layers of different insulating materials of thickness 60 mm and 40 mm. And their corresponding thermal conductivities are 0.24 and 0.4 watts per meter per degree Celsius. The inside and outside heat transfer coefficients are 60 and 12 watts per square meter per degree Celsius. The atmosphere is at 20 degrees Celsius. Find the rate of heat loss from 60 meter length of pipe. Solution. Here is a diagrammatic view. Given. Radius R1 equals 0.06 meters. Radius R2 equals 0.12 meters. Radius R3 equals 0.16 meters. Thermal conductivity Ka equals 0.24 watts per meter per degree Celsius. Thermal conductivity Kb equals 0.4 watts per meter per degree Celsius. Heat transfer coefficient of hot fluid HHF equals 60 watts per square meter per degree Celsius. Heat transfer coefficient of cold fluid HCF equals 12 watts per square meter per degree Celsius. Temperature of hot fluid THF equals 65 degrees Celsius. Temperature of cold fluid TCF equals 20 degrees Celsius. Length L equals 60 meters. Finding the rate of heat loss. Which equals 3,850.5 watts.